You might be someone who is confident teaching an engineering course, but what if you were asked to teach a liberal arts class? Researchers at Montana State University wanted to know what would happen when an expert in one field tried to teach in another field, especially to find out if or how it changed their teaching techniques. The research looked at 25 PhD students who had already completed master's degrees in natural science, social science, or the humanities. Collectively, these participants had extensive undergraduate teaching experience and regarded themselves as above average in teaching effectiveness. The experiment was simple. Participants taught for 20 minutes a concept from inside their own academic discipline. Later, they would do the same with an introductory concept from a discipline other than their own. These activities took place within the classroom session, with the other participants role-playing undergraduate students. The participants were at ease and effective when teaching in their own discipline, using informal anecdotes, guiding discussions, and showing examples. However, they were anything but comfortable when teaching from outside of their experience. Participants wrote records about the out-of-field presentations, which included comments like, "I felt lost up there, it was awful. I was overwhelmed, totally inept, very hurried. Good grief, we reverted to lecture." That's right. When presenting foreign material, these instructors reverted to monologues. No stories, no discussions, no examples, and no requests for feedback. While you might not have to go as far as teaching a liberal arts class, you will inevitably have to teach outside of your field of experience. More importantly, it is not unusual to have students from different disciplines and with diverse backgrounds. This means that you'll need an interdisciplinary approach to teach them, especially if you're going to teach them effectively, rather than just favoring the sage on the stage approach. To help you in these endeavors, researchers from Harvard's Project Zero have provided 3 strategies to assist you in integrating different fields based on the nature of bonding among disciplines and their role in guiding the quest for knowledge. They proposed 3 strategies: contextualizing, conceptualizing, and problem centering. We'll explore contextualizing first. Contextualizing is a method of embedding any disciplinary material in the fabric of time, culture, and personal experience. When you contextualize, you make the knowledge more human by situating it in history and society, providing crucial information for understanding and retaining it. This strategy is most closely associated with the humanities, as art in all its forms becomes richer upon learning about the context that it was created in. However, it can be applied to any subject. For example, calculus was invented in the 17th century in order to solve problems in the context of physics and geometry. Trivially, we contextualize on a daily basis. For example, you decide what to wear in the context of the weather, the time of day, and where you are going to be. Contextualizing often tries to connect the knowledge and the learner on a personal level, asking the learner to view information in the context of his or her own life. A professor might also ask a question, how long did the Roman Empire last? This may appear to be a straightforward question at first, but requires further clarification. When did Rome become an empire? Was it when Rome was first established? Perhaps not, as it was merely a town at the time. Was it when it controlled the whole of Italy, or does an empire require the possession of provinces? By integrating interdisciplinary knowledge in anthropology, sociology, and history, we give the question more context and invite more satisfactory answers and more thorough knowledge of the subject. As engineering educators, your students might not appreciate the significance of some important concepts without a suggestion of how the concept relates to them personally. What is one example of that you've experienced? What context would you share in order to help them appreciate it? Now we'll move to our next strategy for interdisciplinary teaching, namely conceptualizing. Conceptualizing is an integrative strategy designed to take scientific and mathematical thinking beyond the facts and singular theories to the level of the underlying concepts. Conceptualizing identifies core concepts that are central to two or more disciplines and establishes a rigorous quantifiable connection among the different disciplines. Contextualizing and conceptualizing can be easy to get confused. Just remember, conceptualizing connections are anything but metaphorical or suggestive. The goal of this mode of integration is not to interpret human experience, but to understand essential laws of the world that operate regardless of our perception and interpretation. Conceptualizing digs deeper than contextualizing, because rather than being aware of parallel information that is dependent on who you ask about it, conceptualizing examines underlying truths that are universal for everyone. In our daily lives, we conceptualize when we consider our motivations for an action. For instance, in choosing to pursue a college degree, we may be motivated by the desire to support a family or attain prestige. We may perform a specific action, but it is often motivated by a greater underlying objective. In a way, all of engineering is conceptual. In chemical engineering, you might discuss power plants. That involves combustion, a chemistry concept, as well as the use of turbines, which entails mechanical, electrical, and material sciences. Combustion and turbines are examples of broadly applicable concepts that pertain to the more specific task of power generation. How would you explain to your students the difference between contextualization and conceptualization? How does recognizing the difference between subjective connections and fundamental objective laws help your students to pursue knowledge effectively? Finally, we'll discuss the third strategy, that of problem centering. Problem centering uses an ill-structured, real-world problem as an axis of connection among disciplines. Problem centering enlists the knowledge and modes of thinking in several disciplines to examine messy, real-life problems that require more than one discipline to solve. Problem centering is aimed at generating tangible outcomes and change. Problem centering can help us answer questions like, is there one move that is more likely to win a game of rock, paper, scissors? A winning strategy in rock, paper, scissors depends on math, probability, psychology, economics, and even operations research. More aggressive players might choose scissors, for example, while players who are savvy in pop culture might choose rock based on a reference to it in a Simpsons episode. Rock, paper, scissors experts need to take every variable into account and cannot depend on one discipline alone to give them all the answers. This is true of larger challenges like water pollution, for example. A problem-centering strategy would integrate knowledge of political science, economics, chemistry, biology, agriculture, and business to solve a multidimensional, real-world problem like this. Problem centering lends itself well to class projects that give students real-life experience, although they are within the classroom. What scenarios would you pose to your students? What other disciplines might they incorporate into the problem you pose? While there are disciplines and concepts that lend themselves well to one strategy over another, contextualizing, conceptualizing, and problem centering are each useful in their own right and can help you achieve your goal of effectively and actively teaching. Remember, there is not one perspective from which to describe and experience the world, be it mathematics, chemistry, physics, or biology. Even when combined, these perspectives may clarify some aspects of the world while clouding over others. They are dialects with which we retell our own existence. These are inks with which we write our scripts. But each discipline alone only tells a fraction of the story. Harnessed together, they give rise to depth and tone and color. As you apply these strategies, you and your students will benefit. Tell us how in the comments below.